morning, student. I am NV Krishna Rao, Assistant Professor in CSE Department. I am handling compiler design for the 5th semester. So here today we discuss the compilation process. So what is the different steps in compilation process that we discuss now? So which we are using to convert high level language to low level machine level language. So this is the compilation process. Initially, we take the skeletal source program. That will be the input to the preprocessor. The main task of the preprocessor is to execute, to evaluate all the preprocessor commands. This is the advantage of preprocessor commands. Hash include is one of the preprocessor command, and if we use a functions, there is a transfer of control from one statement, one function to another function, and we will save the status of the program and function both on the memory stack, and we will execute this function and we will return back. So here, if we use a function, when we want to repeat a task for some number of times, we use a function. But when we use the functions, they will be a transfer of control and coming back, storing the data, everything will be taken. So the execution time is more. But if the function size is less, then we use the preprocessor commands. So what this will do, if a function body is 2 lines or 3 lines, we will give a preprocessor label and followed by the 3 statements. So whenever the label is occurred, this preprocessor will replace the label name with its respective statement lines. So it will be continued. It will be continued. So when preprocessor process the program, it will replace all the preprocessor labels with the statement. So we are avoiding the rewriting of the statements and we are saving the execution time. That is the advantage of preprocessor commands over the functions. The condition is the size of the function should be less. Right? The size of the function should be less. Okay. So whenever we use the preprocessor commands, the statements, number of statements should be 2 or 3. Then we use the advantage of the preprocessor. If it is more number of lines, then better to use the function. So the first one is preprocessor. So here we will process all the preprocessor commands. Then the output of this preprocessor is source program. It will consist the source program. It will be input to the compiler. Right? It will be the input to the compiler. Here the compiler will have multiple phases. Normally we use 6 phases. So the source program will go through all the 6 phases of a compiler and it will convert high level language to assembly language program. So the output of this compiler is assembly program. This assembly program will be the input to the assembler. Right? This assembly program will have the mnemonic codes and some symbols which represent the instructions. So this assembly program will be the input to the assembler. So this assembly program will be the input to the assembler, and this assembler will convert this assembly program to relocatable machine code. So the output of this assembler is relocatable machine code. Right? Output of this assembly program is assembler is relocatable machine code. Here we can move this machine code from one system to another system where we want to execute the program. Then we will use the link and load editors. We will use the link editors, load editors to convert this relocatable machine code to absolute machine code. So what is the task of Flickr? What is the task of load editor? Then the link editor will combine the object code of the all header files included in this program. I'm saying hash include std.h. Then hash include is preprocessor command. The object code of the std.h will be included into our current program with the help of this link. Okay, if we use a hash include string.h, so the object code of string.h is included into our source program. So this task of this linker is to include the all the objects of the header files and any other files we are included, then that file's object code is included into our current file program. Then load editor. The load editor, its main task is to assign memory locations for all the temporary variables, all the variables and programming statements, programming code such that it make it to be executable, right? So unless a memory is allocated, the programs cannot be executed, right? Here we will get the absolute machine code which can execute by taking some input and gives the final output, right? So the load editor, its a main task, assign memory locations to the programming code, all the variables and temporary variables and also for the statement to make it the program to be executable. So that is the complete compilation process, right? So the preprocessor. So here if we observe, hash define is all the preprocessor commands are preceded by hash symbol. Here hash define, we are declaring function of x comma y and this is the statement. This is the preprocessor label and name and here this statement is the respective statement. So whenever it observes a function, it can be replaced by this statement. So for example, we have a equal to this one, function of a comma b. Then it will become as this statement. So whenever it observes function a comma b, then simply it's replaced with respect to statement, right? So here we avoid the writing the same statement multiple times and it may sometimes it may result to the typing mistakes also. So we can eliminate the possible errors also, right? So and whenever a preprocessor will see this preprocessor label a function x comma y, simply it replace the function name with the function body. Okay. So hash include header.h replace the contents of the file header.h. So hash include is also one of the preprocessor command and here these are the other examples of the preprocessor command. Hash define, hash include, hash undef, hash if defined, hash if not defined, hash if, hash else, else if, end if, error, program. These are the defined preprocessor commands which have some certain meaning. So whenever the preprocessor will see these commands, it will perform its respective task. Here a hash and if already that label is defined, now we are removing its definition. If the label is if the label is defined, do some task. If not defined, do some other task. So as if def, we will specify some statement if it is already defined. Hash if and def. So if it not defined, now we make it to define and do the some task. Right? So these are the some examples of preprocessor commands. So in general, the programmer will use the editor. Right? So using the editors, we write the program. So the output of editor, we are writing the source. The source program will be input to the compiler. The source program will be the input to the compiler. Then the compiler will convert this high level source program to intermediate level assembly level assembly code. So it will convert to the assembly code. This assembly code will be the input to the assembler. This assembly code will be the input to the assembler. Then what is the task of this assembler? Will convert this assembly code to the machine code. Assembly program will consist the symbols and mnemonic codes. So these symbols and mnemonic codes will be converted to machine code, which consists ones and zeros. Then linker. Here the task of the linker is to connect all the with the object code of the header files. If any other programs or files are included, then it will include the object code of the other programs and files. So here it will give the solve the machine code. Solved machine code. Then next task is loader. Here the loader will give the executable code. It will assign a memory locations to all the program statements and variables and also temporary variables so that the program can be executable. Right? The program can be executable. Here, when you use the compiler, simply it convert the first high level to the low level. But if you use a debugger will help to check the execution of the program step by step, statement by statement. So using the debugger, we can check the execution of each line. So if any errors occur, we are getting the correct result, then no problem. If any errors occur, then we use the editor to once again rectify the errors, and the complete process will be once again repeated, so to get a correct execution. Right? So editor, compiler, assembler, linker, loader, debuggers, these are the different things that we use in the compilation process. So the linker combines the object code, machine code that has not yet been linked, produced from compiling and assembling many source programs as well as standard library functions and resources supplied by the operating system. So the linker main task combine the object code of header files and other programs to the current program. So that is the main task of the linker. So this involves the resolving the references in each object file to external variables and procedure declared in other file. So when we are connecting, when we are in our program, when we are using the external variables, then using this help of linker, we can connect to that respective files and we can access the external variables and procedures. Then loader. Here Compilers, assemblers, and linkers are usually produce code whose memory references are made relative to an undetermined starting location that can be anywhere in the memory. So these are the relocatable machine code it will generate. But the loader will allocate a memory locations to each and every statement of the program, and it assign for all the variables, temporary variables, to make it executable. So that is the main task of loader. So here the main here, it will recognize all the legal programs. If any errors will occurs, simply it will generate the error message. It must generate the correct code. That is the main target of this compilation process, right? So here, if any found any illegal characters or statements, a code, simply it will generate error message. To finally it recognize legal programs, and it should generate the correct code, and must manage storage of all the variables. With the help of a loader, it will allocate a memory for the all the variables, and it must agree with operating system and linker on the target format. Here, it needs some sort of intermediate representation. The front end maps source to intermediate representation. The back end maps the intermediate representation to target machine code. Right? So assembly program are intermediate machine code, intermediate representation will be used here to convert source program to intermediate representation, and from the intermediate representation to target machine code. So the front end and back end, the phases of a compiler will separate with as a front end and back end. So front end will convert the source program to intermediate representation. The back end of the compiler will convert the intermediate representation to target machine code. So this is the complete compilation process. So in the remaining concept, we'll discuss in the next class. So I'm closing this section.
Like, share and subscribe. Hit the bell icon for more updates.